Okay, everyone. So in this video, we'll look at VCE 2017 further math examination exam 2, and we're still doing the recursion and financial modeling topic. It start from question 5 on page 10. So now let's start. Still, I'm just going to work through the thinking step I have. Like, when I look at the questions, I won't read all these things. The first thing that I'll see is these two equations over here. So the first one I have V naught equals to 75,000, and the second one is Vn plus 1 equals to Vn minus 3,375. So I know that this topic is about recursion and financial modeling, so I already start my mindset into the recursion mode. Now, so in the recursion, I know I have arithmetic sequence and I also have geometric sequence. Now it's very easy to identify that this sequence we have over here is the arithmetic sequence, so there will be a common difference between them. And if you go back to the question, you will see this flat rate method of depreciation. So I don't even to memorize what is flat rate method stands for, whether it's simple interest or compounded interest, because the clue is all given to me over here. So now let's start with the question. I have V naught at 75,000 and V1 equals to 75,000 minus something. So here what I need to know is it's asking for me to find out the pattern of that, and I already identified that this arithmetic sequence, and we been given the term that Vn plus 1 equals to Vn minus 3,375. So if my n is equals to 0, so when my n is equals to 0, I'll have the equation that my V1 is equals to V naught minus 3,375, where my V naught is equal to 75,000. So here we have the equation over here. My V1 is just equals to 75,000 minus 3,375. And if you do the calculation, this is what you get. Now V2, so if for my V2, if we want to follow the equation over here, so my V2 now became my Vn plus 1. So if my V2 is equal to Vn plus 1, then my 2 is equal to n plus 1 over here. So my n is equal to 1. So the Vn plus 1 equation has just been changed into V2 is equals to Vn, or n is equal to 1 over here. So I'll have V1 minus 3,375. So, and from the previous term, we know that my V1 is equal to 71,625. So that's why I'm going to write over here. Minus 3,375 and carry out the calculation, and equals to 68,250. Now question B, by how many dollars is the value of the one depreciated each year? So a clue over here is by how many dollars. So if it's geometric sequence, it will ask us by how many percent, or because it will be a rate over here. So normally that will be by how many percent. But how many dollars means that we will have a common difference over here, and it's depreciated. So that means that we don't need to include the negative sign over here. So the answer will be just 3,375, because in each year the value of that is $3,375 less than the previous year. Part 2, calculate the annual flat rate of depreciation in the value of the one. Write your answer as a percentage. So what it's saying over here is asking us to find out how much it was to its original value. So the amount of depreciation each year is 3,375, and the original value is 75,000. So if I want to find out how much it depreciate each year as part of the original value of the one. Even though it doesn't say the original value, but in the value of the one, kind of already giving you the clue that you're just going to do that to the original value. Otherwise, the percentage is changing each year. But they want us to have just one percentage over here, and you can see that it works 1 mark, so it will be pretty straightforward. Just depreciate the month over the total value of the month and times 100% because they want us to represent in percentage. So after I found out that this part is equal to 0.045, I'm going to convert that to my percentage sign. So what I'm going to do is I'm just going to treat the percentage as a unit. So I'm going to times the 0.045 part with the 100 over here. So that will give me 4.5, and then I carry down the percentage sign. So that will become 4.5%. So my answer over here will be 4.5%. Now the the part C. So the value of the LX1 could also be depreciated using the reducing balance method. So the previous method that we've been using is called the flat rate. It's called flat rate methods of depreciation. And now we have it called the reducing balance method. So we have flat rate and reducing balance. And flat rate, if flat rate is about arithmetic sequence, then my reduced balance over here is going to be my arithmetic sequence. It's going to be my geometric sequence. So flat rate is simple interest and reducing balance is my compound interest. So we can say that the value of the one in dollars after n years, Rn, can be modeled by the recurrence relationship shown below. So we have a starting value of 75,000, and then for each year, it only worth 0.943 of the previous year's value. So now it's saying that at what annual percentage rate is the value of the one depreciate each year. So a common mistake will be just put because the R over here for my geometric sequence, I know that my R is the ratio of my previous term of my later term over the previous term. So in that case, it will be R. My R is equals to my R. The larger R is the value of the one in that year. So here I have my rate ratio over here. So R, my uppercase R n plus 1 is the value of the one in the later year, and Rn is the one in the previous year. So if we do that, then we can find out from this equation over here. I'll label it as equation number 2, equation number 1. So from this equation over here, if I rearrange it by dividing Rn to both sides of the equation over here, so that Rn on the right hand side have been moved as to the denominator side, and Rn divided by Rn is just equals to 1, so that has been cancelled out. Then my Rn plus 1 over Rn is just equal to 0.943. So a common mistake will be putting 0.943, or if you notice that it asks you to represent it by percentage, you will put 94.3% over there. But this is wrong because what it's asking us is the one depreciated each year. So we need to find the depreciated amount, and this is how much it worth of the original. So the depreciated percentage is by what percent it has been reduced by. So we know that it's 0.943 of the original. Then the part that has been reduced by will be 1 minus 0.943. And we still want that to be represented as percentage, so I'm going to do times 100% over there. And 1 minus 0.943 will be 0.07, not 7 over here, 5 0.057 times 100%. So still I'm going to treat my percentage sign as a unit over here. And I'm just going to times the numerical part. So 0.057 times 100, so I need to move my decimal place 2 places to the right, and that become my 5.7, and my percentage sign got copied down. So the amount of the annual percentage rate is the value of the one depreciated each year is 5.7%. Okay, so question 6. Question 6 says that Alex sends bill to his customer, and if you don't pay the bill by the due date, you will be charged with an interest. Now, Alex charges interest after the due date at the rate of 1.5% per month and the amount of unpaid bill. And the interest will compound monthly. So part A, Alex and Marcus a bill of $200 to repairs to his car. Marcus paid the full amount 1 month after the due date. How much did Marcus pay? So now the first thing we noted is that after the due date. So after the due date, according to the question over here, an interest of 1.5% per month will be charged. So upon an unpaid bill. So the unpaid part is $200. So what Marcus need to pay is the $200 which he owned and plus a interest. So plus 200 times 1.5%. So if you do the calculation, the it will equals to $203. So the answer is Marcus need to pay $203. Now, Alex sent Lily a bill of $428 to repair her car. Lily did not pay the bill by the due date. Let AN be the amount of the bill n months after the due date. Write down the recurrence relationship in terms of A note AN plus 1 and AN that models the amount of the bill. So we know that if you don't pay the bill at all, the amount of interest will be compounded monthly. So it means that you will pay the interest for interest as well. Okay, so at the start, which is A note, because it asks us to represent that in terms of A note. So at the start, Lily owns $428. Okay, but because she didn't pay her new at the pay her bill at the end of the first month, then she will need to pay this amount plus 1.5% of what she didn't pay. Right? So what she didn't pay is a note or 428. So because it asks us to write down the recurrence relationship in terms of that, so I'm going to change these 428 in terms of a note. And here I need to times the 428 as well. So I'm going to represent that as a node. So that will be, so it's still A1 over here. That will be a node plus 1.5% of a node. All right, in the second month, she need to pay everything she owned for the first month. So plus a 1.5 interest of everything she owned in the first month. And in the third month, which is A3, she will need to pay everything she's owning up until the end of the second month. So that's A2, and also an interest based on whatever she didn't pay. Okay, so if you look at the pattern over here, if I have A1, then I have A0 and A0 over here, A node and A node. And if I have A2 at the start, then I have A1 and A1 at the right hand side. And if I have A3 to the left, I have A2 and A2 to the right. So the notation over here is always one larger than what I have on the right hand side. So I will put my AN plus 1 term over here, and my AN plus 1 term will be what she didn't pay in the previous term and a 1.5 amount of interest paid of the part that she didn't pay. So if I write down a recurrence relationship, then I will have my A node is equals to 428, and my AN plus 1 is equal to AN plus 1.5% AN. And this is a 2-mark question, so you will get 1 mark for identifying your A node and 1 mark for finding out the relationship between AN plus 1 and AN here. Now, part C, Lily paid the full amount of her bill 4 months after the due date. How much interest was Lily charged? Round your answer to the nearest cent. Okay, so one thing to note is that 4 months after the due date, so your N that you're looking for over there is going to be your A4 here. This it depends on which equation that you're using, and if you're going to use this geometric sequence equation, then you're going to look at A4. If you're going to use this equation, you're going to look at A4. But if you use the geometric sequence equation, which is Tn equals to A plus A times equals to A times 1 plus R over 100 to the power of n minus 1, then you use n for a different equation. But because we have represent our terms in terms of an, so we just look at the equation that we have got over here. So if we want to know what is after 4 months, so we're looking for the value of A4 over here. What I have in the right hand side of my equation will be AN, so 1 less than the A4, that will be A3 plus 1.5% of my A3. And what you need to do is find the, so now I have a continuous equation over here, so I know that my A1 is equal to 428 plus 1.5% of 428. So from that, I can calculate out my A2 because that's so from that I know that what my A1 value is, and I can substitute the value of A1 into the A2 equation to find out A2, and from there to go find out A3, and from A3 to find out A4. So that's definitely one way of doing it. The other way is you can do it by the terms method, and as I said, because you're actually starting with A node over here, so A node is your first term. So if you want to use this equation over here, you need to start with, you need to find out T5, because your first term, which is your T1, is going to be equals to 428. Then your T2 is going to be equals to your A1. And your T3 is going to be equals to your A2. So this is, and then from all the way, when you want to find your A4, you need to look at T5. What does T5 equals to? So if you do it that way, you will have your, so I'm looking for my T5, and my T5, where my n equals to 5 is equal to 8, which is the starting term. That's 428 times 1 plus the rate we find it out is 1.5%. So R is equal to 1.5, or I will just write 1.5% over here. And n minus 1, my n is equal to 5, so it's n to the power, it's 1.5 to the 1 plus 1.5% to the power of 4. So that's 1.015 to the power of 4. Answer is equals to 454.264. Now, first of all, the question asks us to find out what's the interest that she need to pay. And then second, so what's the interest she has to pay? And secondly, it asks us to round it up to the nearest cent. Now this is the total amount of money that she have to pay. The interest will be that minus how much what how much she was originally charged. So the bill says she need to pay for $428. So we need to minus that by 428, and if we do that, it's equals to 26.2636, and we're going to round it to the nearest cent. This is where my cent is. I need to look at one decimal place after that. So because it's 3, which is less than 5, I will go. My answer is going to be $26.26. And then you can also use the compound interest method because the rate that we use is the interest. So instead of using ratio in this question, I skip a step, just using the interest over here. And so that becomes inside our bracket from our geometric sequence equation and our compound interest equation are the same. So I'm not just going to explain that. But so for n over here, instead of like my n equals to 5, so looking at the term where my n is starting at 5, now I'm just going to say how many compounded period that the interest has been charged for. Now because it says 4 months after the due date, 4 months after the due date, so the interest has been compoundedly leveled up by 4 months. Now our principal, which is the starting investment or starting money that she owns, is 428. 1 plus 1.5%, still the same, and to the power of 4 over here. Now, and also after finding out the total amount you need to pay after these 4 months, you need to minus the number by 4.28. So take away that from my final value over here, and then you will end up with the same answer. Question 7. So he's inviting 360,000 and invested this amount in perpetuity. The perpetuity earns interest at the rate of 5.22 per annum, and the interest is calculated and paid monthly. So paid monthly, that's what we need to know, and it's per annum. So the interest rate is given as per year, but the interest is calculated and paid per monthly. So what monthly payment will Alex receive from this investment? What we need to do is we need to do the total amount of investment, and if we times it by 5.2%, it's how the amount of interest that he's earning per year. But because that we want to know what monthly payment that he's getting, so we need to divide it by 12 over here. And if we do that and calculate it out, our answer will be 1,560.